Hey everyone, welcome to The Explainer. Today, we're tackling a phrase that is literally everywhere right now, large language models, or LLMs. But we're going to do things a little differently today. Instead of getting bogged down in dense theoretical jargon, my goal is to strip all that away and look directly at what this AI actually does in practice. We're zeroing in entirely on punchy, concrete examples of how these advanced systems operate out in the real world. So if you've been wanting to get a firm, practical grip on how these models are designed to understand and generate human language, you are in the exact right place. Okay, let's dive right into this. The big question we always have to start with is, how does AI actually understand us? Well, it all starts with its diet. These models are trained by scraping massive chunks of the internet. We're talking the entirety of Wikipedia, millions of GitHub repositories, decades of dense research papers. But here's the kicker. They aren't just memorizing facts. They're actively mapping the hidden patterns of human language to become a usable, active tool. And that brings us to what they can actually do. Imagine writing a college-level essay in, 5 seconds? Generating a perfectly functional Python script, totally from scratch, translating dense technical manuals from Japanese to English, or even holding a super nuanced customer service conversation. Instead of just handing you a list of blue links, the system is actively creating new content based on those learned patterns. All right, let's break down Section 1, decoding the LLM acronym. First up is the large part. And by large, I mean hundreds of billions, sometimes even trillions of parameters. If you think of a parameter as a tiny adjustable dial, these dials help the AI weigh the relationship between different concepts. To tune all those millions of dials, the system digests petabytes of data. It's essentially absorbing the collective written history of the internet to map out exactly how our human ideas connect. Next up, we have language. Now this goes way beyond a simple dictionary lookup. The model maps context. It knows, for instance, that the word bank means something completely different when it's sitting next to the word river versus when it's sitting next to Wall Street. It's calculating grammar, tone, and these incredibly complex relationships between words to mimic actual, natural human communication. And finally, the model. Stripped of all the Hollywood sci-fi hype, a model is really just a massive neural network functioning as an ultra-fast probability engine. It isn't thinking in the way you or I do. It's actually running incredibly complex prediction math against those billions of parameters we talked about to figure out exactly what should happen next. So what exactly is it predicting? Well, in LLMs, it all comes down to determining the next most likely word, or token, technically. It breaks words down into little chunks and essentially plays the world's most powerful, high-speed game of autocomplete, layering token after token to construct a logical, cohesive thought. Moving right along to Section 2, the 4 flavors of LLMs. So notice the contrast here between broad capabilities and hyper-focused tasks. General-purpose LLMs, like OpenAI's GPT or Google's Gemini, handle a massive variety of inputs, chatting, reasoning, drafting emails. But instruction-tuned LLMs are specifically optimized to execute exact commands. You don't just casually chat with them, you give them a precise directive. You say, summarize this 40-page article, or write a Python program to sort this data, and they just execute. The next 2 flavors really push the boundaries of what these models can process. Domain-specific LLMs are fine-tuned on highly specialized vocabularies. Think ingesting decades of case law for legal tech, or dense medical journals for healthcare. Multimodal LLMs, on the other hand, well, they break the text-only barrier entirely. Multimodal models process the world much closer to how you and I do. They ingest images, audio waveforms, video frames, and complex documents directly alongside text. It is a massive leap forward. The model is no longer just reading strings of text. It's visually and auditorily parsing the data. It's hearing sound waves and seeing camera feeds. To really ground that in reality, let's look at some extremely concrete prompts. You can literally hand the AI a photo of a broken engine part and ask, describe how to fix this. Or you can upload a dense, incredibly messy financial chart and just command it to answer questions about this chart, or extract the Q3 revenue trends. It seamlessly merges visual recognition with language prediction to give you a highly accurate answer. Which brings us to Section 3, real-world LLM applications. Just look at the sheer versatility of this toolkit. LLMs are powering the chatbots and virtual assistants we interact with every single day. They're doing heavy document summarization, chewing through 100-page legal contracts in seconds. They are doing programming and code generation, text generation, creative writing, and even seamlessly translating live conversations across dozens of languages in real time. And on the analytical side, it is just as disruptive. Professionals are deploying sentiment analysis to instantly parse 10,000 Amazon reviews and pinpoint the top customer complaint. They're automating data extraction and classification from messy, unstructured invoices, using them for deep research assistance, and, as we just saw with multimodal systems, leveraging image understanding to diagnose issues straight from a photo. Let's wrap up with Section 4, the future of interaction. Because of this incredible versatility we just walked through, LLMs are rapidly embedding themselves into our core infrastructure. They're acting as personalized one-on-one tutors in education. They're completely revolutionizing business workflows, cutting software development cycles in half. And in healthcare and scientific research, by cross-referencing massive biological databases, they're even helping researchers identify brand new protein structures. Literally, every sector is leveraging this predictive math. Which leaves us with this final critical question. As parameters scale up, as instruction tuning gets sharper, and as those multimodal boundaries completely disappear, how will these systems change the way humans interact with technology? We're moving so fast from a world where we had to command machines with rigid, exact syntax to a world where we just converse with them natively. It's an absolutely fascinating shift. I really hope this explainer gives you a concrete grip on the mechanics driving it all. Keep exploring, and I'll see you in the next one.